Well, hi folks, welcome to Matrix Uploaded, welcome to mathematics and grade 10s to 12s. You need to be focusing in and concentrating, especially you grade 10s. We're going to start at the beginning with you guys and go right up to you grade 12s. And remember, grade 12s, you need to listen to the very first lessons as well. Watch them, master them. They are so important for matric. Let's kick off with linear number patterns. This is very exciting. I want you to consider this little number pattern. Have a look at it. What do you notice? 3, 5, 7, 9, and 11. So guys, what's happening? If you're going from 3 to 5, what are you doing? Yes, someone said it. I heard that. I heard it on TV. Someone said you add 2. Of course, yes. Okay, wow, this nation is getting strong. You're adding 2. Okay, what's happening from 5 to 7? You adding 2. Have a look at this. Isn't this amazing? It's getting bigger and it's increasing in terms of 2's there. Now have a look here. We can set this out quite nicely. There's 3, 5, 7, 9. And have a look at this. The difference, they call it a constant difference between 3 and 5 is 2. You're really saying 5 minus 3 is 2. And look, 7 minus 5 is 2, 9 minus 7 is 2. So there we get what we call a linear pattern. They give this funny name called linear. Okay, now watch this. If we take this further, we call that the first term, T1, T2, T3, and T4. The little 4 and the 3 here represents the position of the term. That's the first term, second, third, and fourth. And here we have a constant difference. Now, I'm going to be a little bit sneaky. Check this out. I want you to consider this rule. Tn is 2n plus 1. What on earth am I doing? Now, don't panic. What is this rule doing? Now, check this. You can see that I know that my first term is 3, then we add 2, giving you 5, 7, and 9. So what's the fifth term? T5. Well, if we add 2, we get 11. That's the fifth term. Okay, what is the sixth term? Well, add 2 and you get 13. But now my problem comes is, what if I want to work out the millionth term? That's going to take a lot of time to do, and we don't have time to do that. Now this little sneaky rule, Tn, watch this, 2n plus 1 is a magical little formula. You might not know where it comes from, but don't panic. Look at this. T1, now remember we've got the n, Tn is 2n plus 1. Now the n's become 1, look at that, T1. So T1 is 2 times 1 plus 3, 2n plus 1, which is 3, and that's the first term. Look at this, T2 is 2 times 2 plus 1. Remember, it's Tn is 2n plus 1, and that gives you 5. Do you see what this rule's doing? It's giving you the terms. Let's carry on and see what happens. Check this one out. Now remember, what are we dealing with? Just look at me. Tn is 2n plus 1. I've given you that. Where on earth does it come from? We don't know, but I'm going to show you. But that rule, or another fancy word for it is a general term, helps us to find many more terms. Now look at this. If you look at the third term, let's go back to the Wacom here. The third term is 7. Now if we use the rule Tn is 2n plus 1, the n's Tn, 2n, the n is 3. So it's T3 is 2 times 3 plus 1, which is 6 plus 1 is 7, gives us the third term. What about the fourth term? Well, the n's are 4. T4, Tn, 2n plus 1, so you replace the n's with 4 and you get 8 plus 1 is 9. Do you see what this is doing? Isn't it exciting? Okay, now here we've got the pattern and we're going to get the fifth term. What's that? It's 11. How did we do it? Tn, 2n plus 1. I've given you this. I'm not sure. I haven't showed you where it comes from, but look what Tn is 2n plus 1 is doing. Okay, it gives us any number of terms. Now T5 is 2 times 5 plus 1, which is 11 there. Okay, and then what's the next one? 13. So let's see if it works. All right, T6. Look at that. 2 times 6 plus 1 is 13. So the sixth term is 13. And so we can get the 7th and the 70th. Look there, T7, and it gives you 2 times 7 plus 1 is 15. Now we can get T70, 2 times 70 plus 1. But the problem is, how on earth did we get that? Well, let's have a look. How did we get the rule? Now I'm going to I don't know what the 2 and 1 is. So what I do is I go Bn plus C. Let's just call that something we don't know. And if we get the first term, we replace it with 1, we get B plus C. The second term is 2b plus c there as well. The third term is 3b plus c. You're just simply replacing into this thing. This is, we don't know what 2n plus 1 is. We know that so we're going to treat it as bn plus c. Okay, if we do this, we put the first term, second term, and third, and we minus. Okay, 2b plus c minus b plus c. 2b minus b is b. The c's vanish. 3b minus 2b is b, the c's vanish, and so forth. Now look at that. That's going to be pretty cool. Now watch this. If you circle those, now bring into play our number pattern. That's that's the first term, b plus c. That is going to be your little constant difference. So b plus c is 3 and b is 2. Now watch this. There's b and b plus c. So if you go like this, all right, here we go, b and b plus c. B is 2, but b plus c is 3. But what do you know about b? It's 2, so c is 1. Isn't that cool? You bring it across, 2 plus 1 is 3. And then we've got our b is there, and look at that. We've got our rule, and that generates the rule. Isn't that cool? Let's check out another one quickly. This is the nth or general term. Okay. All right, guys, now what we're going to do is I want you to hold on to this, and I want us in the next part of the lesson to pursue this a little bit forward. B plus C. Don't go away. We'll be back.